So now I'll be explaining the standards that we took in quarter 3. The first standard is GC09. In this standard, I learned about how to prove that the vertical angles are congruent, and when a transversal crosses like two parallel lines or two or more, to find the corresponding and congruent angles, the alternate interior and alternate exterior angles, and prove that they are congruent. I also learned about what a perpendicular bisector is, and a perpendicular bisector is basically a line that cuts through a segment like equally and cuts it into two equal parts at 90 degrees. The next standard is GCO10. So in GCO10, in the standard I learned about proving theorems about triangles. So we learned about basically that a triangle is 180 degrees and how to find the center of a triangle. That's by taking the midpoint of each segment of the triangle and connecting it to the opposite vertex, and the middle is the point where all the lines from the different segments cross by each other. So I can use this in real life if I wanted to build a building that's equidistant to 2 to 3 other buildings. And if I wanted to build it in the middle, I just have to take a map copy of it, draw a triangle, and find the midpoint. So the next standard is GCO 11. In this standard, I learned about proving the theorems about parallelogram. I know that I learned it because I can explain it. So for example, if I wanted to prove a parallelogram is a rectangle, no, if a rectangle is a parallelogram, I have to see if the two opposite sides are parallel. So I can do that by finding the slope, and to do this I have to use the slope formula, which is y2 minus y1 over x2 minus x1. And then I have to multiply the two different slopes I found together and multiply them by each other, and the answer has to be -1 because for it to be a rectangle, the two slopes have to be negative reciprocals. Another question, it can be like proving that a quadrilateral is a parallelogram. So the properties of a parallelogram are that the opposite sides are congruent and its diagonals bisect each other. So if I wanted to prove that a quadrilateral is a parallelogram, I have to see these things in it, and also that the opposite segments are parallel. So the next few standards are about similarity, right triangles, and trigonometry. So I combined GSRT1, GSRT1A, and GSRT1B. So in these standards, we learned about dilating a shape from a point by a certain scale factor. So either you can make it bigger or smaller, but usually to make it smaller, it has to be like 0 point. To make it bigger, it's like above 0. So the way that, for example, if there's a triangle that I want to uh, make bigger or dilate at with the points of 2, 2, 8, 2, and 4, 6, then I want to multiply it, I want to make it bigger by a scale factor of 2. I have to multiply each of the coordinates, like this, and this, and so it becomes larger. And I learned this because we can this is something basic in geometry, so we can use it to make shapes larger. So we can use it to make shapes larger and smaller. So this is the example that I came up with. So the way that you can prove that this triangle is the same as this one is to see that if the original and the image and the point of dilation, if we draw a line, that it goes through all of them. So all three of them go through all of their image and the original and the dilation point. So that means that this triangle and this triangle are congruent. So the next standard is GSRT2. In this standard, I learned to identify if two shapes are the same or not. Like if two triangles are given to me, I can identify that they're the same or not. Seeing that both triangles have two angles that are the same, it means that they're congruent. But if that's one of the ways. So in architecture, similar triangles are used to represent doors and how far they swing open. So that's how it can be used in real life. The next standard is GSRT3. In the standard, I learned how to use the angle-angle postulate to prove that two triangles are similar. The angle-angle postulate states that for two angles to be congruent, they have to have two corresponding angles. It also states that if all three corresponding sides have the same ratio, this is supposed to be ratio, then the two triangles are congruent. So that's what I learned in GSRT 3. GSRT 4 is about the additional property, the segment additional property. For example, if we have segment AC and B is the midpoint, then AB plus BC equals AC because AC is cut in half by B. We can use this in not just lines or segments, but also angles. This can be used in real life if someone wanted to build like a skyscraper and know how tall they wanted it to be. They can say like that the building, saying that like the building is a segment and the starting point is A and C and the midpoint could be B. Next standard is GSRT 5. In this standard, I learned about rotating a triangle and proving that the two are congruent. We can prove this by measuring each side that has been rotated and using the side-side-side postulate. I also learned about the reflexive property. The reflexive property basically says that, like, for example, if the square PQRS is given, proving that this square is PQRS is PQRS. I combined GSRT 6, 7, and 8. So basically, in these standards, we learned about the sin, cos, and tan. We use this to find either the hypotenuse, opposite, or adjacent side of a triangle. I think out of all the standards that we learned in this quarter, this is the one that we can use most practical. So we even, in one of the tasks in my previous video, when I explained it, we had to find the width of the river. Like, we used this one, and you can use this to find like a lot of things in real life. Like, for example, in this example, you can find we can use it to find the height of this building right here. So this side is the hypotenuse, this side is the opposite, and this side is the adjacent. So the next few standards are about expressing geometric properties with equations. GPE1, in GPE1 we learned how to rederive an equation from a circle using the radius and the center. So basically the center of the circle and the radius will be given to us, and we have to make an equation and form the circle. So for my example, I used the center as 1, 2, and 1, 2 is HK, and 6 is the radius, and so radius is, the formula is right here, so the radius is supposed to be right here. So when we input the values in the equation, it would be x minus 1 squared plus y minus 2, because 1 is h and 2 is k. And 6 is the radius, so we put it right here. So now we can use this equation to form a circle, and this is what the circle would look like. The next standard is GPE2. In this standard, we learned about redriving an equation of a parabola using the focus and directrix. So basically, it's the same thing as the standard before but this one, it's for a parabola. So for the example that I chose, my focus is 4 and 9, and the directrix is y equals 8. So we use this equation, y equals 1 over 2 in brackets b minus k, brackets x minus a to the power of 2 plus half times b minus k. So the focus, which is 4, 9, is a and b, and the directrix, y or like k, is 8. So we put the values that we have inside the formula, and then we form it. So basically, we do 9 minus 8, which is 1, and 1 times 2 is, 1 times 2 is 2. So then 1 over 2 will be 0.5, and then we solve this one, and then we multiply 0.5 with each of these, so with this, this, and this, and then after we get the value, we add what we already did here, which is 9 minus 8, which is 1, and then we multiply it by 2, so it'll be 1 over 2, and it'll be 0.5, so 8 plus 0.5, and the equation of the circle, the parabola, the equation of the parabola will be 0.5x squared minus 4x plus 8.5. So the next standard, GPE4. In the standard, I learned how to prove and disprove that a shape with given coordinates is or is not the shape that is says it is. So for example, if I wanted to prove the shape with the corners with the coordinates of A 10, 8, B 12, 7, C 9, 6, and D 11, 5 is a rectangle. How do I do that? So we know that the opposite sides of a rectangle are parallel and that the slopes have to be like negative reciprocals, meaning they have to equal -1 when they're multiplied together. Also, the two parallel lines must have the same slope. So here is my rectangle, or I have to prove that it is. So the slope of AB is 8 minus 7 over 10 minus 12, and it'll be -1 over 2. Slope of CD is 6 minus 5 over 9 over 11, which is also -1 over 2, so AB and CD are parallel. The slope of AC is 8 minus 6 over 10 minus 9, which is 2, and the slope of BD is 7 minus 5 over 12 minus 11, which is also 2. So it means that AC and BD are parallel. So now we have to multiply the two slopes to see if it equals -1. And it does equal -1. So we've used all the tools to prove it. So this means that ABCD is a rectangle. So the next standard is GMD 1 and 3. So I combined GMD 1 and 3. In these standards, I learned how to find the volume and the surface area of different shapes like the cylinder, sphere, cone, and triangular prism. The formula for finding the volume of the cone is V equals half pi r squared h. Volume of a cylinder is V equals pi r squared h. Volume of a sphere is V equals 4 over 3 pi r to the power of 3. Volume of a triangular prism is half times base times height times length. I know I've learned this because I can explain it. For example, if I wanted to find the volume of a softball with a diameter of 4, I use the sphere formula, which is V equals 4 over 3 pi times r to the power of 3. So the reason why I put 2 instead of 4 here is because radius times 2 is diameter, so diameter divided by 2 will be the radius. So then I put radius here, and then I multiply pi with radius to the power of 3, so 2 to the power of 3, and the answer will be 25.13, and then I have to multiply 4 over 3 times 25.13, which is 33.5. So that is the volume of the softball. So the next standards are modeling with geometry, GMG 1, 2, and 3. In this standard, GMG 1, 2, and 3 are about using GMD 1 and 3 in real life. So for example, Alzealia Banks has a room and in her home, which is perfectly cylinder. So it's 20 feet tall and 15 feet across. Alzealia Banks needs to have the room repainted. What is the total surface area that will be needed to be painted? That will be needed to be painted. So we use the surface area formula for the cylinder, which is 2 pi RH plus 2 pi r squared, and we put the height over here and the radius over here. The radius is diameter divided by 2, and then after we've entered this, we do the the calculations and then we add them. So the surface area will be 120